Now, the universe began with a big bang, and for some time, there was nothing but very hot matter flying in all directions at the speed of light. Very shortly, though, the first star appeared. Its name was Methuselah, and for a long time it confused astronomers who believed it might be older than the universe itself. Soon after, on a cosmic scale of course, the first black holes started forming. Scientists believe they're what's left of exploded stars, but that's not for sure even today. At the same time, cosmic dust and matter began ionizing, helping to form new stars. In the end, it led to thousands and then millions of stars appearing in space. The universe, left cold after the initial enormous explosion, started heating up again. In about 100 million years, stars began forming clusters, which we know as galaxies. The earliest of them didn't include any planets, though. It was still too soon for matter to shape into something so big and solid. So, galaxies mainly consisted of stars and interstellar gas. The oldest ones are believed to have been born in a relatively small patch of sky called Hubble Ultra Deep Field, named so after the Hubble Space Telescope. It includes over 10,000 galaxies. After some time, the first known exoplanet was born. It was also dubbed Methuselah for its incredibly old age. It's moving in the orbit of two stars at once, located 12,500 light-years away from Earth, which then didn't even exist. And of course, I wasn't around either. Soon after, though, the Milky Way finally began taking shape. Our home galaxy is a barred spiral, which means it has a bar at the center and several arms, and on top of one of those, our solar system would eventually be born. Right now, it's no more than a roughly circular blob, though. The Milky Way started forming only about 200 million years after the Big Bang, like many other galaxies. But only now it's becoming closer to what we know and love. At the same time, millions of other galaxies burst into existence with stars and planets clustering together. About 11.5 billion years ago, a peculiar planet popped up. Captain B is the oldest known exoplanet, uncannily similar to Earth in everything. Nobody knows if it's inhabited, but it sure can be. It had more than enough time to develop life. Although spiral is the most common type of galaxy out there, we know the name of probably the oldest one. It's BX 442, whose light reaches us across 10.7 billion years. At about the same time, the rate at which stars were appearing across the universe reached its peak. Every second, thousands upon thousands of new stars would burst into existence, immediately starting to gravitate toward each other, forming clusters, and then later becoming galaxies. At this point, the temperature of the universe slowly began to fall. Until now, it was hotter than the sun's surface and quite dense, like me. But starting 11 billion years ago, it all changed. Powerful galactic cores and newborn stars stopped sending out so much energy into space, and the first metal-rich stars began appearing. Metals made them cool down at a higher rate, so the universe stepped on its track to becoming habitable. With less than 10 billion years before humans appeared, the first group of galaxies emerged, JKCS 041. It's the farthest known galactic cluster, born just 200 million years before the universe reached a third of its current size, a mere moment on a cosmic scale. And at roughly the same time, Barnard's star appears in the Milky Way. It's one of the most ancient stars in our galaxy, and also our close neighbor, being just 6 light-years away from the Sun. As the universe continues to expand, the Milky Way goes on growing in the familiar shape. Until about 8.8 billion years ago, it had only its thick disk, a structure around the center where older gas-rich stars mostly dwell. Now the thin disk starts forming. It's a thinner layer within the thick disk, in which younger stars, more abundant in metals, appear. Stars still get born at an astonishing rate in our galaxy, as well as in many others across the ever-growing universe. That is, until about 8 billion years ago, when this growth rate finally began to subside. This occurred with lots of other galaxies too, of course, mostly because there was not enough matter to form new stars in such a cluttered space. Then, roughly 7.5 billion years ago, something happened a long way from our galaxy and a gamma-ray burst began traveling across the universe, reaching Earth only in 2008. Such bursts usually occur because of a star exploding into a supernova, and they're really spectacular to behold, But this one was special. It was the furthest and brightest one ever observed in history. If it were as close to us as the Sun, it would be 21 quadrillion times brighter than our star. That's 15 zeros, just so you know. Although events such as this happened in the far corners of the universe, it continued to cool down at an ever-increasing pace. About 7.2 billion years ago, the average temperature of space was only 5 degrees Kelvin, or minus 450 degrees Fahrenheit. Still, it was only a few degrees warmer than it is today at minus 454 degrees. In the end, the universe will eventually reach the absolute zero, the temperature at which atoms don't move at all, and space will be dark and absolutely still. Anyway, it's still way long before this event, and we're now at 6.5 billion years ago, the time when the Milky Way started taking its recognizable spiral shape at long last. Now, it won't be long until our solar system forms, but there are still things to come before that. Many of the older galaxies have already taken their current shapes, and stars kept forming and exploding, leaving behind quasars and black holes, which in their turn gave birth to other galaxies. 6 billion years ago, and dark energy, the most mysterious force in the universe to this day, somehow accelerates the speed at which the universe expands. No one is still sure how it does it, but the facts are these for the moment. Gravity isn't the only force that keeps objects apart in space. Still, nobody knows much about this strange energy, so nothing is certain. 5.5 billion years ago, the solar nebula began collapsing. It's important for us because this nebula is what would eventually become the solar system. Right now, it's no more than a ginormous cloud of interstellar gas and dust, and it would take another billion years for it to clump together and form our star and the planets orbiting it. In the meantime, the Milky Way has finally become a complete barred spiral as we know it today. New stars forming, supernovae exploding, all of this had never stopped happening in space. And yet there was one event, roughly 4.6 billion years ago, that mattered the most to us: the formation of the Sun. The cloud of dust and gas I mentioned earlier had finally collapsed enough to form a star, and it took just another couple of million years for the Earth to be born. It was extremely hot back then, and there was no chance for any life to survive. But after a few 100 million years, the miracle happened, and the first living creatures appeared on the planet's surface. Since then, a lot of things, both good and bad, came to Earth, but in the end, here we are, on the most unique and undoubtedly beautiful planet in the whole known universe.